Welcome to lectures on digital electronics. So we are discussing the design of sequential circuits. In that we have already discussed resistors, shift resistors, and after that we have discussed counters. In the counters there are two types: asynchronous counters and synchronous counters. Asynchronous counters receives the main clock in the first stage only. In the succeeding flip-flops will take previous outputs as clock input. So that is the asynchronous counter. That means the clock signal is not applied simultaneously to all the flip-flops. So in the asynchronous counters, we have discussed the decade also, decade counter, the counter which will count up to 0 to 9. And after that we have discussed synchronous counters. In the synchronous counters, the clock signal is applied simultaneously to all the flip-flops. So that is the synchronous counter. So in this, we have to follow certain procedural steps to design the synchronous counter by utilizing excitation tables. So because you do not have such a requirement in your syllabus, so we are skipping that procedure, and directly we have written input equations, input design equations for the counter. Today, now let us discuss memory and memory related terminology and the types of memories available to us. And these are the, so what is resistor? Resistor is a group of flip-flops. What is shift resistor? Sequential circuit which can store information and transfer or shift upon a command. What are the applications of shift resistors? Like this, we have studied all these. So memory is where the program and data are stored before a calculation begins. So that means first the data has to be stored in certain area so that that data can be taken and calculation may be performed on that particular data. And not only that, after calculation results are produced, and these results also must be stored appropriately in certain memory areas. So for that, memory plays important role because the commands, the sequence of commands are called program. So the sequence of commands, that is the program, is to be stored in the memory. Then after that, the microprocessor or microcontroller will take that program and execute it. Accordingly, it performs its job. Memory plays important role. So during calculation, it will store intermediate results, and the data can be read and written into the memory. So let us see the read operation. Here, the memory read operation in this, the here the definition is it is for write operation. It is for write operation. So write operation is the process of storing the information in a memory is known as write operation. So next, read operation. This is the read. That means the process of retrieving the information from a memory is known as read operation. Access time. The average time required either to read from or write into a memory for a fixed amount of information is defined as access time. So next, memory capacity. The total number of bits a memory can store is its capacity. Address lines. Each memory location is identified by a label known as address. Word length. The number of bits that can be stored in one memory location is known as word length. So, a device that stores information in electrical or magnetic or optical form is known as memory. So, that means memory which will store the information in electrical form or magnetic form or optical form. So, this is the memory here. It has memory locations like this and so on. So this is the zeroth location, 1, 2, 3, 4, like this up to n locations. So this, for example, let us take a single memory location. This is the single memory location I want to take. So this is the memory location. In this, if you, for example, if this location can store, if it is 8 bit, then you have to call it is the word length of this memory is 8 bit. If you are able to 16 bit, then you have to call it as 16 bit memory word length. Like that you. According to the principle of operation, the memory can be divided into, according to the principle of operation, sequential access memory, read and write memory, read only memory. These are the classification of memory according to the principle of operation. Content addressable memory. In the sequential access memory, the data is stored or retrieved sequentially, that is the sequential access memory. Read write memory here, that means the data can be read or write from memory from any location at a time. The read only memory, that means the data can be read from memory, it cannot be written into the memory. Next, content addressable memory, that is the content which is to be read from the memory is compared with each memory location, and this is called content addressable memory. So the sequential access memory, this memory accessed in a sequential or serial fashion, access time is different for different locations, because now according to the functional relationship with CPU, that means how it is accessed by the CPU. Based on that, the memory can be classified as main memory, next auxiliary memory. According to the method of access, so direct access memory is there and a sequential access memory is there. According to type of accessing allowed, read-only memory, data is permanently stored. The data cannot be corrupted in the read-only memory. Only read operation, no write operation. So that is the read-only memory. Next, read-write memory. So this is data is temporarily stored. Both read and write operation is performed. So let us consider the memory classification according to the device used in the memory technology. that is the bipolar technology is used, then such memories are called bipolar memories. If we use MOS transistor, then we call it as MOS memories. And according to the retentivity of stored data with respect to availability of power, we can classify the memory into two types, that is volatile memory, that is stored data is lost when power is off. Examples: RAMs, and non-volatile memory, in which the stored data will not be lost, it will be retained when the power is off. So that is non-volatile memory. Examples are ROMs. So according to the state of data transfer, we can classify the memory into destructive readout memories, that is whenever copying data without destroying its source place. So that is the with if the data is copied uh, with the destructive readout, that means whenever you read it, if the data is lost, then it is called destructive readout memories. Non-destructive readout memories, in which data is cleared after read operation. That means in this memory the data will not be disturbed in the source location if you read the data. Whereas in the destructive, if you read the data will be lost. According to period of storage, we can classify the memory. So how much time the data will be stored. Based upon that, we can classify static memory and dynamic memory. So static memory is composed of storage elements such as flip-flops that are capable of retaining the information as long as the power is on. The data is stored in the flip-flop. That is bipolar memories. So that flip-flops are constructed with the transistors. So that is bipolar memories. The dynamic memory, this is a memory which is having cells that tend to lose the storage information over a period of time and therefore must be refreshed. So that is a dynamic memory. That means though the data is not accessed, it is not accessed or transferred, then but the dynamic memory, the stored data slowly it will leak away. That means after some time the total data will disappear. So that is the problem. So this problem can be eliminated with the refreshery circuits by reloading the same data into the dynamic memory after certain time. So such additional circuits are required. How the data is lost? Because in the dynamic memory, the storage element, basic memory element, is constructed with the capacitor. That is the problem. So the capacitor, it will store the data as a charge. So the charge will be slowly discharged after certain time. So that is the problem. So it is called leaking of the data. So this is a dynamic memory. So we can classify the semiconductor memories into broadly ROM and RAM. ROM is the read-only memory, that is only reading is possible. The data is read and that data cannot be written into the ROM. So that is here in the ROM we have masked ROM and PROM, programmable read-only memory, and EEPROM, erasable programmable read-only memory. Here is EEPROM, and EEPROM, that is electrically erasable programmable read-only memory. So now RAM, read-write memory. In this read-write memory, that means the data can be read from the memory and the data can be written into the memory. So this is the read-write memory RAM. We have in this static RAM, that is the data will be retained without any disturbance. So that is a static RAM. As long as the power is on, the data is available. That is the static RAM. Whereas in the dynamic RAM, though the power is on and everything is fine, but the data is leaked, slowly it will disappear after certain time because of the data stored in the capacitors. So they will discharge. So that is the dynamic RAM. So that problem will be eliminated with refractory circuits by reloading the same discharged amount of the charge by recharging it once again. So that is a dynamic RAM. So let us see what is this RAM and ROM. The differences is RAM is temporary storage. That means the data is available when the power is on. If the power is off, the data will be lost. So that is the temporary storage. ROM is the permanent storage. So here, if the power is on or off, the data is permanently stored. So that is the ROM. Next point, stored data in megabytes. That means large amount of data cannot be stored in the RAM because RAM is manufactured in small sizes. Okay. So whereas the ROM store the data in gigabytes. So gigabytes here, that means large amount of data can be stored permanently and its capacity is more when compared to RAM. So the RAM is volatile memory because data is available when it is on. Data is lost when it is off. So that is a volatile. And the non-volatile ROM is the non-volatile in which the data is not affected with the power off. So after power off also you have your data. That is the ROM. So fourth point, RAM is used in normal operations and ROM is used for startup process of computer. So that means operating systems and programs are stored in the ROM. RAM, writing the data is faster. That means fast accessing is possible with the RAM, and with the ROM, writing data is slower. That means you have to require additional circuitry to write the data, that is CD writer, like that. So let us see the block diagram of the memory unit, in which this is the memory. Here, if you observe, this is the main memory, which is having n words, and each word is m bits length. So like this, for example 0 1 2 up to memory n, up to n. Each location size is, for example, 8 bit. For example, 8 bit. So 8 bit data can be stored in this single location, 8 bit data. So word length is 8 bit. So this is a memory. So the design of the memory is like this. You can call it as n by m memory, n by m memory. For example, uh, 10 by 8 memory, 10 by 8 memory. That means 10 by 8 memory means it is having like this 0 1 2, like that, and so on up to 9, up to 9. That means 0 to 9 locations, 0 to 9 location. Each location stores 8 bit data. Each location stores 8 bit data. That is you can write it as, the memory can be written like this. This is the memory, and it is 10 by 8 memory, 10 by 8 bytes, 10 by 8 bytes. So that is the here. If you observe, so the address comes from the processor CPU to this memory like this. So there is a memory address register. So with this address, the memory is accessed. The memory is accessed. So how it is accessed? Based on the address. So the address is decoded, and chip select is generated, and certain memory location corresponding to this memory, one of the memory location is activated. And after that, the CPU sends one of these control signals, that is read control signal or write control signal. For example, if the CPU send a write control signal, then what happens is the CPU will place some data on the data bus. So this is the input data bus, IO data bus. Generally, this is input output data bus. So the data is placed on the bus. This is the data. Now you see the sequence of operations, how the communication is done between CPU and memory. CPU first sending the address, and one of the memory location in this is activated, and after that the CPU activated write control signal by placing the data here. After placing data, it will issue write control signal. So this data, for example 2 the data is sent through data bus and placed in memory location 2. For example, if the CPU wants to read data from, for example, eighth location. This is the eighth location. Then the CPU will send the address to this, and based on this address, this chip is selected, memory is selected, and one of the location, that is the eighth location, is activated. For example, eighth location is having the data 23. Already the eighth location is having the data 23. Hence, after issuing the address, then the CPU will activate the read control signal. Once read control signal is activated, what happens is this 2 3 data is comes out through data bus. It is placed in the buffer register. From the buffer register, it comes to the CPU. It comes to the CPU. This is the reading of data from the memory. Now, if you observe here, this is another memory architecture here. This is the M by N memory. M locations and N is the word length. So this is the one memory. And if you observe, so additional gate circuitry is also necessary for proper communication of CPU with this memory. Hence, this is the additional circuitry. Here, address. CPU sends the address through the buffer, address buffer, and row pre-decode and column pre-decode circuits are there, which will decode the address issued by the processor CPU. And what happens is the control circuit also, you see, the row decode and column decode will activate one of the memory location, so based upon the selected memory location, and this control circuit will issue control signals to row decode, column decode, and IO driver, thus activating whether read operation is to be done or write operation is to be done based upon the read write control signal received through CPU. For example, CPU wants to read the data. CPU wants to read the data. That means the CPU takes the data from the memory. At this situation, read write control signal is activated. So the control circuitry will activate the row decode and column decode by appropriately by selecting one of the memory location. After that, out of the selected memory location, the data is placed on the data bus. IO driver will drive the data to the data bus out. So through this data bus, the CPU will take the data from the memory. So this memory is dynamic memory, hence column precharge is circuitry. This is the column precharge as circuitry is included in this because to refresh the dynamic memory is necessary because the data is lost after some time. So let us consider a ROM using diodes. Here this is the construction of the ROM. So observe here. So there are 8 rows and 4 columns. 8 rows and 4 columns. And to select one of the to activate one of the 8 rows, a decoder is there. So this decoder will activate one of the row. So the decoder receives the control signals, that is address signals A0, A1, A2 from the CPU. So the CPU send A0, A1, A2 address to the decoder. Based upon the address status, one of the output is activated. So once one of the output is activated, the activated line, for example, let us take for example this line is activated. So this line is activated, all other lines are deactivated. That means all other diodes are reverse biased. That is the thing. So how the connection is made, if you observe, I want to tell you one important point. That is, for example, these are the rows. For example, these are the rows. So 1, 2, 3, 4 rows are there. And columns, if you observe, like, let us take, these are the columns. These are the columns. If you see, there is no connection between row and column. You see, columns are here. These are the columns. These are the rows. There is no connection between row and column, but there is a diode connected between row and column, like this. Like this, a diode is there between row and column, but they are not shorted. That is a thing you have to remember. They are not shorted. If you see like this, we think that they are shorted. If you see like this, we will think that they are shorted, connected, but not that case. You see, there is no contact. So that is the connection diagram here. And based upon the CPU send 000 control signal, address signal. 00 means row 0 is activated. Row 0 is activated means this diode will conduct. There is a diode here, that diode will conduct because it is activated. And here there is no diode. At the second column, there is no diode. Between row and column, there is no diode. At the third column, you have the diode. That means row is connected to column, and now diode is conducting means there is a short contact between row and column. Diode conducts means contact is there. If there is no diode or diode not conducting means open. So that is the thing you have to remember. So this is also conducting. So hence this, because this is conducting, this is not conducting, three are conducting, one column is not conducting means this row is active high means it is 1. It is 1. This 1 is coming to D3. So if you read D3, it is 1. All other diodes in other rows, every diode other rows are off because they are not activated. Only 0th row diodes also only conducting. Hence D3 is 1. Here D2 is, because there is no diode, there is no contact between row and column. Hence it is in off. It is in off. That is 0. This is 0. And here there is a contact. The diode is conducting, hence it is 1. Here is also 1. That means 1 0 1 1. So whenever 00 is given as address input to the decoder's memory, then 1011 data we are getting. So the data is fixed. So that means the information. So this is the masked ROM. Its construction is very simple. They are arranged, diodes are arranged in rows and columns. And whenever a particular row is activated, then only a contact is made between row and column, thus giving the data 1. If there is no diode means definitely there is no data of 1, that is it is treated as 0. And during the manufacture, the manufacturer will arrange the diodes in rows and columns like this. That means the data is already prepared by the manufacturer. So that is the ROM. Here the data he manufactured is in the first row it is 1011. In the second row it is 0110. Wherever the diode is there, it is treated as 1. And it is 1001. Next, third row 1011. Fourth row 1111. Fifth row 0010. Sixth row 0100. Seventh row 1101. Like this. So this is the way the manufacturer will store the data. And this stored data can be read by activating one of the row and reading the columns. So that is the ROM construction. So most IC ROMs utilize the presence or absence of diodes or transistors at row column junction to represent a 1 or 0. The row selection is done by using decoder. The row wires indicates the various address lines. The column wires correspond to the data lines. Here total 8 address lines are used. Each address stores a 4-bit data. So the presence and absence of the diode corresponds to the bit stored. At row 0, a high voltage turns on the diodes connected to it and all other diodes are off. Then a high output appears at D3, D1, D0. Hence the stored word at row 0 is 1011. At row 5 we find it as 0010. At row 6 we find it as 0100. Like this. So we have here the address 0000 address. That means whenever 000 address is activated, you can read the data 1011 because 0th row is activated. Data is 10. So you have the lines, data lines. These are the data lines. So these data lines are connected to data bus. Similarly, you have 001, 00010 like that. So these is the data and corresponding address and data. So what is the capacity of the memory? What is the capacity of this room? So the capacity of the room is represented like this. Here, room is 8 locations are there. Each location is storing 4 bit information. So 8 by 4 bytes memory. 8 by 4 bytes memory. So it is having the data lines 4 bit data output. That means D0 to D3. D0 to D3 data lines. How many address lines? 3 address lines. A0, A1, A2. That means internally a decoder is there. You have to remember that. So internally this memory is having a decoder. Once these address lines, through these address lines, one of the address comes means that particular uh, location is activated by the decoder. Already we have seen in the diagram. And next control bus also connected, that is the read control signal. That is the read control signal is active load read control signal is also connected to the memory. So the CPU will send the address. For example, um, it's sending 000 on these lines, address lines. So this is the address. Once this address comes, what happens? Internal decoder will activate the 0th memory location. Whenever 0th memory location is activated, and what happens is 1011 data which is stored already in that location, 1011 which is stored in that location is available on the data lines D0, D1, D2, D3, D4, D3 up to D3, D0 to D3, 4-bit data is available on the data lines. And CPU also issues read control signal. Hence, this data comes to the internal register of the CPU. This data comes to the accumulator, for example. So this is the way of reading the data from the ROM. Only read only possible. So this construction of the ROM is based upon the diode is present or absent. Treat it as whether 1 is stored or 0 is stored in that particular location. Instead of diodes, sometimes transistors also used. Okay, so that you have to remember. One important point you have to remember is that the data manufacturer will already store, the manufacturer will store this data. Already data is provided to the manufacturer. So this data is provided to the manufacturer. So the manufacturer, based upon this data available, he will place the diodes, or whether placing diode and whether not placing the diode is decided based upon this data. So this is the way how the ROM is constructed with the help of diodes. So not only diode, sometimes transistor can be used. Instead of diode, transistors also can be used. So we have discussed the sequential access memory and memory unit and types of memories we have discussed. Now here we have shift register, that is one question. A shift register can be used as memory, ROM, PROM, none. None. The memory which requires refreshing is dynamic memory or static memory? Dynamic memory, because the data is discharges. And which of the following is a volatile memory? Which of the following is a volatile memory? RAM, ROM, both A and B, none. Which one is volatile? Means when the power is on, then only the data is available. Otherwise, the data, if the power is off, data lost. So that is the volatile memory. It is called RAM. So with this we conclude our lesson, and thank you.